Fascinating content ahead. What if we have an army of robots? No more people would die. Bomb-disposing warfare rescue operations would become more effective and less dangerous. Isn't it a life-altering revolutionary step? But are these robots truly capable enough? Curious to know more? Well, here we'll be talking about the 5 most advanced army robots available right now. Hang tight with us till the end of the video. Hello everyone, welcome back to our channel, a versatile place to discuss everything about science, space, robotics, and many more. But right off the bat, we ask that you subscribe to the channel and hit the bell button so that you never miss any of our uploads. So without further ado, let's get started. The United States military has a long history of being at the forefront of humankind's technical advancements. The U.S. Navy, for example, pioneered the use of nuclear power as a propulsion technology in the 1940s, commanded by Admiral Rickover. This eventually led to civilian nuclear power plants. With its robotics breakthroughs, the U.S. military is once again leading the way into the future, and there are numerous applications across the organization's whole infrastructure. The military's robotics spending climbed from $17 million in 2015 to $379 million in 2021, according to National Defense Magazine. That quantity is rising as robots play an increasingly vital part in military operations. Of course, as the number of robots grows, so does the demand for people to work with them. While robots' primary job in the military remains supportive and behind the scenes, such as building, sanding, and repairing equipment and gear, there are some truly interesting breakthroughs being made with robots that play more active roles. Speaking of them, Dogo comes at number 1. It's a type of portable small robot that's been utilized in military tasks for years. However, because of their size, limited payload capacity, and complicated controls, they were mostly used for counter-improvised explosive devices, CIEDs, and reconnaissance. A new combat robot built by Israel's General Robotics will be shown at Eurosatory 2016 to help combat forces in urban assaults and counter-terror operations. The tactical tracked robot called Dogo has enough battery capacity to endure for 2 to 5 hours of duty with a gross weight of only 12 kilograms. A fully equipped Glock 27 handgun with attachments placed on Picatinny rails also has 8 cameras spanning 360 degrees. Non-lethal effects are provided by the equipment carried on the rails, such as a pepper spray module or a dazzler that temporarily blinds an attacker from a distance of 5 to 10 meters. Dogo was created for special forces, SWAT teams, and infantry missions, according to Shachar Gal, VP Business Development at General Robotics. The compact, light robot can travel on firm ground and ascend stairs. In comparison to a human warfighter, the robot has a few benefits. Because the steady platform is more precise than a person and can be handled from a safe distance, it gives warfighters more time to examine the situation rather than reacting instinctively. While the robot's pursuit range is restricted, employing 2 Dogos under mutual cover would keep the target covered even if one of the robots tried to escape or engage the other. The little stealthy robot is built to take on things that are far larger than it. Dogo's weapon may be aimed incredibly low. Even if the targets are laying on the floor or hiding beneath a bed, it can hit them at close range just as effectively as a standing person. The robot features a built-in secured container for the Glock 26 pistol, which is 9 mm long. The weapon is fully loaded with 14 rounds and can be rapidly connected to the Dogo using a remote-controlled safeline system. The Ranger Remote Control Unit RCU, manufactured by General Robotics, is used to control the Dogo robot. The RCU uses a ruggedized Panasonic FZG1 touchpad, which is covered in a jacket and provides the robotic controls. The RCU has joystick controls for navigating the robot, as well as a pointed shoe interface that allows the user to guide the weapon towards a target by touching it on the screen. Operators who have mastered the technique after only a few weeks of training have shown the ability to bring weapon and firefighter shots within seconds. On number 2 is Mars. The DCSN 1242 bot is a powerful modular and combat-ready weapon. Advanced Arms robotic system with modular activation. It is an autonomous ground vehicle meant to improve the security of soldiers stationed at forwarding areas by performing reconnaissance, surveillance, and target acquisition tasks. Mars can be stationed in remote places where personnel are currently unable to monitor security and can be equipped with either a direct or indirect fire weapon system. Mars is a flexible and combat-ready system that keeps warfighters safe from enemy fire while completing security operations. Mars allows for a remote deployment of RSTA sensors in crucial sites up to several kilometers distant, allowing for early warning and, if necessary, fast response. Mars has numerous day and night cameras, motion detectors, and an acoustic microphone aboard, as well as a hostile fire detection system and a loudspeaker system with a siren to offer the best situational awareness and alert. When the rules of engagement necessitate it, Mars may even give a variety of choices for escalation of force, ranging from non-lethal lasers, dazzlers, and audio deterrents to less than lethal grenades to fatal discharges from the Great Launcher or medium machine gun. Mars is also incredibly safe and tamper-proof since it can only work when its operator gives it correctly programmed instructions. Mars' ruggedness and robustness, coupled with the unique ability to remotely deploy sophisticated sensors and force application capabilities to significantly improve the security of forward bases and outposts. Saphir is ranked third. The U.S. Navy has shown off a prototype of their Saphir shipboard autonomous firefighting robot. It wasn't much more than an aluminum core with 2 legs the last time we saw it, but today it resembles a future firefighting humanoid. We set out to create and show a humanoid that can move around a ship, manipulate doors and fire hoses, and sense and navigate through smoke using sensors. At the Naval Future for Science and Technology Expo, Office of Naval Research Program Manager Thomas McKenna stated that the long-term aim is to keep sailors safe from direct fire exposure. Saphir, created by Virginia Tech researchers, is 5 feet 10 inches tall and weighs 143 pounds. The robot can see through dense smoke thanks to infrared stereo vision sensors and a revolving laser. Saphir, unlike DARPA's Atlas robot, can't stand on its own, but it can take measured steps and handle a fire hose. For the time being, such movements are controlled by humans. Saphir collaborated with a tiny drone during a test run in November, according to Gadget reports. The quadcopter DC-21 employs infrared sensors and cameras to identify flames and maps of an area's terrain, which it can subsequently relay to the robots. The Navy is aiming to improve Saphir's speed, intelligence, and communication capabilities by developing more modern sensors. The drone's makers also intend to improve the DC-21's battery life, which now stands at 5 minutes. Saphir's ultimate purpose is to operate with Navy officers rather than replace them. They're working on putting together human-robot teams. It's what we refer to as the hybrid force, in which people and machines collaborate. The RoboBee is the next on the list at number 2. It's insect-inspired robots that might be used for agricultural pollination, search and rescue operations, surveillance, and high-resolution weather, climate, and environmental monitoring, among other things. The Wyss Institute is creating RoboBees, man-made devices that can perform a variety of tasks in agriculture or disaster assistance based on the biology of bees. A RoboBee is approximately the size of a paperclip and weighs less than 1/10 of a gram. It flies using artificial muscles made of materials that contract when a voltage is applied. Some RoboBee versions have been modified to let them convert from swimming to flying and to perch on things using static electricity. The RoboBee's creators were inspired by the notion of developing autonomous and micro-aerial vehicles capable of self-contained, self-directed flying and large group coordination. To that aim, the RoboBee's development is separated into 3 parts: the body, the brain, and the colony. Body development entails creating self-flying robotic insects with the assistance of a tiny and flawlessly integrated power supply. Smart sensors and control circuitry that resemble a bee's eyes and antenna are used in brain development. It can perceive and respond to its surroundings in real time. The colony's main focus is on coordinating the behavior of a large number of individual robots so that they can function as a cohesive entity. To build RoboBees, Wyss Institute researchers use novel manufacturing processes known as pop-up microelectrical mechanical or MEMS technology, which have already substantially enlarged the frontiers of existing robotics design and engineering. Licensing is available in all places where RoboBees are used. Gladiator is the first, and it's meant to help the U.S. Marine Corps with various operations. The Gladiator Tactical Unmanned Ground Vehicle has the appearance of a small tank and may be equipped with a variety of modular tools and munitions, depending on the scenario. The Gladiator's speed for toughness has an armored hull, and users may place machine guns and grenade launchers straight into his body, despite its peak speed of 10 miles per hour. The OSD Joint Robotics Program and the Office of Naval Research financed an RDT&E initiative from 2000 to 2004 to develop technologies that drastically improve the Gladiator's performance capabilities and affordability. In February and July 2004, a team led by Carnegie Mellon University constructed a prototype Gladiator system which was successfully demonstrated. The demonstrations were focused on robotic mobility and robotic reconnaissance, respectively. After the ONR program was completed successfully, the Robotic Systems Joint Project Office in Huntsville, Alabama, held a competitive procurement for the system development and demonstration program. Finalizing the Gladiator design, constructing 6 prototype vehicles, and deploying these vehicles to the Marines for operational assessment in 2006 are all part of the program. Carnegie Mellon University was granted a $26.4 million SDD contract by RSJPO on February 7, 2005. The Carnegie Mellon team is designing and building a Gladiator system that will meet Marine Corps specifications in collaboration with its principal subcontractor, BAE Systems. And this concludes today's video. Let us know if you found this video informative in the comment box, as well as what's your view on these. Also, for more useful videos like this, subscribe to the channel and follow us by clicking the bell icon. See you soon in our next installment. Until then, peace.